Okay, so we're going to do this lesson on describing the distribution, and there are 3 songs that go along with it, but I think that when I've made the recording, when I embedded the videos into the recording, then it makes the other sound not work. So we're going to try this again, and I'm going to make a separate video that includes the songs that go along with what we're talking about here. So let's try this. All right, so this one is, we're going to first learn how to describe the distribution, and then of course distribution is our collection of data and how those are collected to date, how those are put together and graphed and into a histogram, and what type of shape those made is one that we're going to look for. Because when we hear this phrase, describe the distribution, there are 4 things that it specifically wants. One of them is shape. One of them is outliers. Identify those. One of them is give the specific information about the center. And the other is give the specific information about the spread. So we're going to go into detail about those 4 things, and then we'll go over the assignment, and again, the songs that go with this will be a separate video. So let's first look at shape. We're going to look at shape on the next page. Here are the items that I want to look at that will represent the different types of shapes that we have. So if you're in the band and you wear a uniform, then you all look the same. So whenever we have the same amount of items in every bin, we have a uniform distribution. And so each bar of the histogram is the same height. We would also call this symmetrical because it is the same on either side of that line of symmetry. Here we've got skewed right. Skewed right puts the tail on the right. And here we have skewed left. That puts the tail on the left. So people get those confused because they see all this data over here and they think that means the data's on the left, so that's skewed left. No, the skew is where this tail is. So tail right, skewed right. Tail left, skewed left. And then, of course, here is our symmetrical shape that looks the same. These 4 graphs also, in addition to those shapes, would be considered unimodal because they have one peak and one bar that is, or one section that is the highest. Now, of course, this uniform, I guess, doesn't really have a mode. But these 3 have got one peak or one mode. As opposed to this next one down here on the bottom left, it has 2 modes. So that's why that would be referred to as bimodal. It also happens to be symmetrical. Now, bimodal distributions are typically happening because you've got subsets of data. For example, and I'm going to redraw this one a little bit because you don't have to have a blank space in between the 2 sections. You could also have that going on. So we could do this problem and see that we have got 2 modes. We've got this section of test scores of people that did not study. We've got this section of test scores of people that did study. So those kind of clumped together in 2 sections, hence it is called bimodal. Next, if you have more than 2 modes, you don't go into tri-modes and quad modes. You just pretty much call it multimodal. So that would be multi. So now, let's look at these shapes here and name them so that you can practice that. This one here is skewed left, and it is also unimodal. This one in the center is symmetric, and it is also unimodal. This one here on the right has a tail to the right, so that is skewed right. and that is also unimodal. Okay, let's look at this next row. This one here really has got two sections, two subgroups, making it bimodal. And I would consider this also skewed left. This might be something like the female shoe sizes and the adult male's shoe sizes, or kids and adults. Okay, so you've clearly got two kind of subsets there. Here would be a symmetric shape, and it has got multi-modes. And then our last one over here is bimodal, and it is skewed to the right. Okay, now, after we talk about the shapes, then we also want to address the mean, median, and mode relationship. Because by knowing this relationship of the values of the mean, median, and mode, we could also determine a shape from that. For example, if we looked at the numbers, if they were given to us, and we saw that the mean, the median, and the mode were pretty similar to each other, and they were just about equal, then we would know that this is a symmetric shape, and that it's pretty symmetric. But if we had a shape that was skewed left or skewed to the right, then that would be affecting the relationship between the mean, median, and mode. So here's a way that we can remember that. If we write the words in alphabetical order, mean, median, and then mode, look at what you can do. If you have a skewed left, think of putting an inequality layered over that. So skewed left points to the left. And so that means that if you put that inequality in between those two, then the mean is less than the median. And that value is less than the mode. So that's the relationship for a skewed left distribution. Likewise, if you had, let's do this on this third one here, mean, median, and mode. If we had this inequality here, skewed to the right, so it points to the right, then our inequalities between the mean, median, and mode is also a greater than, so our mean is greater than the median, and that is greater than the mode. So in summary, if you were just given the numbers for a mean, median, and mode, you could also determine the shape of the distribution. And also, of course, if you knew the shape of the distribution, then you would know that relationship between the mean, median, and mode. Okay, so that's all about the shape. Now, let's take a look at the outlier. If we know that if we have the lower fence for the Iqr rule, we've already learned that one. So the lower fence is that, lower outlier fence, it is Q1 minus 1.5 IQRs, Q1 minus 1.5 IQRs. And the upper outlier fence, it is Q3 plus 1.5 IQRs, Q3 plus 1.5 IQRs. So that is what you would do if you were using IQRs and medians. But if we end up using means and standard deviations, because those kind of go together, then we have a standard deviation rule for outliers. And this is new today. So our lower fence, and we'll look at this also on page 20. Our lower fence is the mean minus 2 standard deviations. And the upper fence is our mean plus 2 standard deviations. Now, see, I have that written here, mean plus or minus. This is not a 0. This is not 20. This is a lowercase sigma, and this lowercase sigma is a standard deviation. Okay, so that is mean plus or minus 2 standard deviations. All right, now you may wonder, how do you know which one of these sets of rules to use? Should you use the IQR rule or should you use the standard deviation rule? And that is determined based on the shape of the distribution, actually. Because let's go on to center and spread, and then we'll come back to which outlier rule to use. Okay, so we learned when we did pages 8 and 9 in our homework that the mean is affected by outliers. So if you have skew or if you have outliers, then you do not want to don't use the mean. If you have skew or you have outliers, then you should use the measure that is resistant and not affected by outliers. So the median is resistant to outliers, therefore we would use median. So if you have skew, in fact, one of the songs in the next video is, if you have skew, then you must choose to use median and IQR, because the measure of spread, that also is resistant to outliers, because the ends get knocked off. You know, you've just got your nice little box here in the middle, and the ends get knocked off. So the IQR is also resistant to outliers, okay? But if you have symmetry, then you can use standard deviation and mean, okay? So if you have skew, then you must choose to use median and IQR. Ooh, symmetry, use standard deviation and mean. Okay, so that would tell you to use those. Because remember from our page 8 and 9 homework, the standard deviation is also affected by outliers. When we added that 44 miles per gallon Prius into our problem on page 9 in the homework, then we saw that it affected that standard deviation, or that average distance from the mean. All right, so there are the things that are included in what you need to include when you describe the distribution, okay? And again, I have 3 songs to talk about this. So you may want to stop this video, go over to the song video real quick, and then come back. But I'm going to continue this, and I'm going to go on to the homework and start with page 18, because I want you to, on this page, I want to have you describe the distribution. And so the song that goes with this goes, describe the distribution, shape and outlier. So that's your socks. Shape and outlier, center and spread. Okay, so that's what we're going to do with this first one. I'm going to practice it with you. We will describe the distribution, and we will write out shape, outlier, center, and spread. And then we'll talk about that. So obviously, looking at this, we can see that it is skewed left, and it is unimodal. All right. Now, outliers, we might have some over here on this lower side, so I definitely want to do a lower fence. So the question is, do I want to do a lower outlier fence with the IQR rule? Or do I want to use the IQR rule, or do I want to use the standard deviation rule? All right, well, you want to use, that's going to depend on the shape. So let's actually jump to center and spread, and then come back to that outlier. So since we have skew, if you have skew, then you must choose to use median and IQR. Because if you have symmetry, then you'll use standard deviation and mean. Okay, and those are those songs. So therefore, the center we want to use is the median, and we want to be specific. So the median is 94. And the spread we would choose to use if we have symmetry, if we have skew, then we want to use median and IQR. Ooh. And so our IQR is Q3 minus Q1. So 97 minus 86, that is 11. Now, with that being said, knowing that we are using median and IQR, I think you should see that it is natural to use the IQR rule for the outlier fence. So I'm going to compute the outlier fence. Does it look like you should use an upper fence or a lower fence or both? Should I compute both? I hope that you see that you should compute the lower fence. It doesn't appear as though there's upper outliers. So I'm going to do the lower fence, and that would be the lower outlier fence. It is Q1 minus 1.5 IQRs. So when I do that value of 86 minus 1.5 times 11, that brings me to 69.5. So therefore, I can tell that I've got an outlier fence at 69.5 right here. So I can see I have some outliers there. So I can say then that I have several outliers, several lower outliers below, and be specific, below 69.5. Okay, so do you see how we are specific? We give actual numbers for our outliers, the ones that are below 69.5, and the numbers for the center and the numbers for the spread. Now, even if you did not have a picture, so even if this picture was gone, based on these numbers over here on the side, you should still be able to tell if you have an outlier or not. And what would we look at to determine if we have a lower outlier? This minimum. Because if this minimum is below our fence of 69.5, then that tells me for sure that I have got at least one lower outlier. Okay, so you can determine these outliers even if you did not have the picture. All right, so real quickly before we go on to page 20, you can see this one is pretty symmetrical. So since we have symmetry, we'll use standard deviation and mean. Okay, so when we do our center and spread, we'll do the standard deviation and mean. Hence, if we were to look for outliers, then the outlier rule we would use, since we know that our center will be using mean and our spread will be using standard deviation, then we know that our outliers will be using the standard deviation rule. And we're going to kind of talk about that right now on page 20. So your homework is page 18. That's to finish this, describe the distribution. So your homework is page 18, page 19, and page 20. So 19 has just got some other stuff going on there. And then page 20 is about outlier rules. And so we'll go over that real quick, remind you of how to do that. And then this is one of your homework pages as well. So let's recall our two sets of rules. IQR rule We've got the lower fence, so fill that in. That is your Q1 minus 1.5 IQRs, Q1 minus 1.5 IQRs. Your upper outlier fence, it is Q3 plus 1.5 IQRs, Q3 plus 1.5 IQRs. Now, if you need to use the standard deviation rule, okay, then here's that. The lower fence, and I don't have a little song for this, it is mean minus 2 standard deviations. And the upper fence is the mean plus 2 standard deviations. Okay? So let's take a look at this computer printout. This computer printout has got female information and male information. So we've got 2 rows of female information and male information. N stands for the number of items in your sample. We will use mean and we will use median. This is trimmed mean and we won't ever use that. We will use standard deviation. This is standard error of the mean and we will not use that until pretty much March or April in chapter 27. And then here's your min and your max. We will use these, we will look at these to check for outliers. Because if this minimum is below your lower fence, you've got a lower outlier. If the maximum is above the upper fence, then you have an upper outlier. And of course, you'll use your Q1 and Q3 so that you can determine your fences and your IQR. You'll want to come up with those for the female and the males. So you can see on this page 20, what you're going to do is you'll take the female information and you'll find the upper and lower fence with the IQR rule. And then go look at your min and max to see if there are any outliers and if they are upper or lower outliers. And then you'll do the standard deviation rule and see again if we have any outliers and if they are upper or lowers. Then you'll do the exact same thing for your male data. The IQR rule, the standard deviation rule, and then determining if you have any upper or lower outliers. Okay, so that's how you do that. Again, in summary, your homework is pages 18 through 20. All right, so again, there's another video that includes the songs. There's 2 of them to know which measure to use, and then there's the describe the distribution song.